When designing a cloud-based solution, understanding design patterns like microservices and serverless is essential for creating efficient, scalable, and resilient architectures. For plain Nimbus, adopting these patterns can help the service remain agile, manage varying loads, and ensure high availability. Microservices architecture breaks down a large monolithic application into smaller independent services that each handle a specific function. For example, plain Nimbus could separate user authentication, content management, video streaming, and recommendation engines into individual microservices. Each of these services can be developed, deployed, and scaled independently. If the recommendation engine needs more compute power because users increasingly interact with it, it can scale without impacting other platform parts like content management or streaming. This modularity also allows for better fault tolerance. If one microservice fails, it does not bring down the entire application. Cloud providers like AWS and Azure offer microservices platforms such as AWS ECS or Elastic Container Service and Azure Kubernetes Service or AKS, making deploying and managing these services easier. A key benefit of microservices in cloud environments is the ability to mix and match the best tools for each service. For example, the video processing microservice might use AWS Lambda for serverless video transcoding, while the user authentication service could leverage Azure AD B2C for secure, scalable identity management. This flexibility allows plain Nimbus to use the most appropriate tools and services for each part of the platform, improving performance and cost efficiency. On the other hand, serverless architecture eliminates the need to manage any infrastructure. In a serverless model, the cloud provider automatically provisions, scales, and manages the infrastructure required to run code. This approach is particularly useful for event-driven tasks or unpredictable load patterns. For plain Nimbus, a serverless function could be triggered whenever a user uploads a video, automatically processing and storing it in the appropriate format without manually managing servers or infrastructure. Using services like AWS Lambda or Azure Functions, the service can automatically scale to meet the demands of thousands of users who are downloading content simultaneously without requiring any manual intervention. Serverless architecture also allows plain Nimbus to operate more cost-effectively because it only pays for the compute resources used when the function is running, rather than paying for idle servers.